Sound, class 9 Ncert. First of all, let us discuss about the production of sound. Sound is produced when an object vibrates and creates a pressure wave. Propagation of sound. The matter or substance through which the sound is transmitted is called as a medium. It can be solid, liquid, or gas. When the object vibrates, it sets the particles of the medium around it vibrating. Through this vibration, the sound is transmitting from one point to another point. In the previous slide, we discussed about the vibration of sound. Through this vibration, the sound is propagated. But in this vibrational part, there is two regions. One is rarefaction and the second one is compression. It is shown in this figure. The compression is the region of high pressure and the rarefaction is the region of low pressure. The pressure is dependent upon the number of particles in the medium. And the sound takes time to reach the receiver also. As the density of the particle increases, the pressure also increases. That means it will be in a compression state. Sound wave is actually a longitudinal wave. Longitudinal wave means the particles of the medium move back and forth parallel to the direction of the wave is traveling. Sound wave is also traveling like that. That's why the sound wave is a longitudinal wave. Like longitudinal waves, there is another type of waves that is transverse wave. In this transverse wave, the particles of the medium move perpendicular to the direction of the wave propagation. For example, light waves. Let's discuss about characteristics of sound wave. First of all, frequency. Frequency refers to the number of cycles per second. Cycles means one trough and one crest is included in that. It measured in the frequency is measured in hertz and it determines the pitch of the sound also. The second figure, it is given two waves, that is high frequency and low frequency. In the high frequency waves, more cycles will be there comparatively with the low frequency wave. Let us discuss about what is the relation between frequency and pitch. First of all, the high pitch sound. That means the higher frequency means more waves passing through a point per second and result in a higher pitched sound. Its converse is the lower pitched one. Next characteristic is the amplitude of the wave. It refers to the height of the wave from the central line. It tells us the loudness of the sound. In the second figure, the high amplitude and low amplitude wave is given. What's the relationship between the amplitude and loudness? Louder sound means that when the amplitude is larger, then it will make the sound louder. It will carry more energy. Likewise, the softer means the smaller amplitude result in a softer sound. Wavelength, it is the distance between two consecutive compression or refraction. The second figure it is given the long wavelength and short wavelength images. For long wavelength, the consecutive refraction or the compression will be higher than that of the short wavelength. Time period of a wave means the time taken for one complete oscillation. And frequency and time period is inversely proportional. That means frequency is equal to 1 divided by time period. To find out the speed of the sound, we can use a formula that is distance divided by time. In case of sound wave, the distance is the wavelength and the time is the time period. So we will get lambda divided by t. 1 by t means that is the frequency. We can substitute the value here. Then finally we will get speed is equal to wavelength into frequency. Let's discuss about speed of sound in different mediums. According to the mediums, the speed of sound will vary. That means the speed of sound is depends upon the mediums. And then the temperature increases, then the speed of sound will also increases. When we consider solid, liquid, and gaseous forms, the speed of sound will be higher in solid form, then it will decrease to liquid, and then to the gaseous state. Reflection of sound. When sound bounces off the surface of the medium, the angle of incidence will be equal to angle of reflection. Here in this figure, it is given that I is the angle of incidence and R is angle of reflection. Both are same. What is echo? Echo is a sound that repeated because the sound wave reflected back. To hear a distinct echo, the time interval between the original sound and the reflected one must be at least zero point 0.1 second. The minimum distance of the obstacle from the source can be found out by using the formula of speed, that is speed is equal to distance divided by time. By substituting the values of time and speed of sound, we will get the distance that should be equal or greater than 17.2 meter. What is reverberation? It is a repeated reflection that result in the persistence of sound. From this figure, we can see that somebody is playing some musical instrument, and the sound is reflected back from the roof and walls. This is called as reverberation, and to reduce the reverberation, we can use sound absorbent materials. Uses of multiple reflection of sound. First of all, megaphone, horn, musical instrument, all of this having a tube followed by a conical opening reflects the sound successively to the audience. Second one is a stethoscope. It is used in medical field to hear the heartbeat of patients. Third one is the ceiling of concert hall, conference hall. All are curved so that the sound after reflection reaches all the corners of the hall. Range of hearing. Different species have varying abilities to hear sound. For human, it is the audible range is 20 Hz to 20 kilohertz. Different frequency ranges are given below. Frequency less than 20 Hz is known as infrasound and greater than 2 kilohertz is known as ultrasound. As we age, the ability to hear high frequencies often decreases. Let's discuss about human versus animal auditory ranges. Some animal can hear frequencies beyond human capabilities. Some of them are rhinoceros, elephant. They can make infrasounds, and dolphin, bats. They can produce ultrasound. Applications of ultrasound. First one is it is used to clean parts located in hard to reach places. For example, spiral tube or shaped parts, etc. Second one is ultrasound can be used to detect cracks or flaws which are invisible from the outside in the metal blocks. The third application is in echocardiography. It is a technique used to take the images of heart by using ultrasonic waves. And fourth one is ultrasound scanner. It is an instrument which uses ultrasonic waves for getting images of internal organs such as liver, uterus, etc. Sonar, it is a device that is usually used in ships to find out the distance, direction, and speed of underwater objects. From this figure, we can see that sonar is emitting some ultrasound waves and it can detect the direction and the speed and distance of the underwater object. In the previous section, we have discussed about sonar. In this section, we can discuss about the working of sonar. First of all, the sonar having two main parts, that is a transmitter and a detector. The transmitter produces and transmits ultrasonic waves. These waves travel through the water. It is shown in this video, and after striking the object on the seabed, it is reflected back and is sensed by the detector. The detector converts these ultrasonic waves into electrical signals. The time taken for the echo to return to the ship can be measured by the sonar apparatus, and then it can find out the distance. By using this equation, that is 2 into distance is equal to velocity into time, the sonar can find out the distance between the ship and the object in the seabed.